Okay, now I'm back. Now you're asked to find the acceleration of the satellite. Now this is where I think physics is really cool, because there's a couple ways to approach this problem. I'll just show you two. Let's look at what is causing this object to move in a circle, because we know Newton's second law. The sum of the forces equals ma. Well, there is only one force acting on my satellite, and that's the force of gravity pulling it towards the Earth. So I can acknowledge that it's the force of gravity that's causing my satellite to accelerate. That's the mass of the satellite. That's the acceleration of the satellite. Then I can put in the universal law of gravity, big G, times the mass of the Earth, times the mass of the satellite, over the distance between them squared, equals ma. The masses go away, and I'm left with an equation for acceleration. It's big G times the mass of the Earth over r squared. Now again, you are not given r. R is the distance from the center of Earth to where the satellite is. It's the radius of the circular path. But you were given this distance and this distance. So you can go ahead and plug those in, and you're left with the acceleration. That doesn't look like an A. Let me fix that. The acceleration equals big G times the mass of the Earth over this value r, so that's going to be the radius of the Earth plus h quantity squared. Now, you also can ask yourself what type of acceleration this is. This object, this satellite, is moving in a circle. So that's centripetal acceleration, and you can easily derive the equation for centripetal acceleration even if you don't know it. Here is the equation for centripetal force, but recall that the net force equals mass times acceleration. Well, this just happens to be net force in a circle, so this is circular acceleration or centripetal acceleration. When you set these two equal to each other, you're left with mv squared over r equals ma sub c. Cross out your m's, and you're left with the centripetal acceleration equals v squared over r. Many of you probably remember that. Even if you didn't, it's okay, because we just derived it. Now you can say, well, what's the speed of the satellite? Well, that was the question you were asked earlier. So plugging in this value for speed into v, we are left with the square root of g times the mass of the Earth over r, which is the radius of the Earth plus the altitude above the Earth. This is going to be squared, because that's squared, all over r. So the centripetal acceleration is big G times the mass of the Earth over r, all over r, which is big G times the mass of the Earth over r squared. Now, when you plug in the value for what little r is, that is the distance from the center of the Earth to where the satellite is. It's also this distance, or the radius of the circular path. You will see that you will get the same answer as we saw for over here.